Okay, this next video is actually going to cover 2 pages of the review packet because this next section bleeds over from page 3 into page 4. So I figure we'll just go ahead and do one video for both the 3rd and 4th pages of your review packet. So here we have, we're being asked to find the value of a variable or a question mark using basic trigonometry. So these are SOHCAHTOA problems. So on your reference sheet you need to locate your SOHCAHTOA. And we're going to use it over and over and over again to solve problems. Now remember what this is saying. This is saying that sine of any angle is the opposite over the hypotenuse, cosine is the adjacent over the hypotenuse, and tangent is opposite over adjacent. If you don't remember what that means, you need to go back. You need to go back to section 2-1 in your notes, section 2-1 in your notes, and your textbook, and you need to review because you will not do well on this final if you do not understand SOHCAHTOA. Bring your questions to class and let's get it figured out. Okay, so in number 20, we are given a 72-degree angle in a right triangle. We are given that the adjacent side, which is the side directly next to it, is 6, and we are asked to find the hypotenuse. Now notice I've written adjacent and hypotenuse. So we go to SOHCAHTOA and we figure out which one we're using. If we have adjacent and hypotenuse, that would be cosine. So we say the cosine of the angle, 72 degrees, is adjacent over hypotenuse, 6 over x. And then we're going to solve that equation for x. So we're not even going to think about using the calculator until we have x completely by itself. Now the first thing we do is we get x out from underneath the fraction, and the way that we do that is we multiply both sides of the equation by x. That gives us x times the cosine of 72 degrees equals 6. Now at this point, this is like having 3x or 4x. To get x by itself, we need to divide. So we're going to divide both sides of the equation by the cosine of 72 degrees. So x is 6 divided by the cosine of 72 degrees, and we're going to feed that to the calculator. 6 divided by the cosine of 72 degrees. Now that's not a nice decimal. It is 19.41640787. Significant figures were not introduced this early. So what I would like you to do is I want your answers rounded to the nearest hundredth. That's 2 decimal places. So I would want to see 19.42, and that should be units. Let's do another one. So here we're asked to find the angle. So let's go ahead and write an x in here instead of this question mark. Now if we look, what we're given is the opposite side and the adjacent side. So again, we just need to think to ourselves, okay, what do I know? What am I trying to find? Well, I'm trying to find the angle. So I need to think to myself, well, I've got opposite and adjacent. That means I'm using tangent in this problem. So the tangent of the angle, tangent of x, equals opposite over adjacent. Now these are probably the easiest ones to do because in order to get rid of the tangent, we have to take the inverse tangent of each side. So we are taking the inverse tangent of each side of this equation. Now on the left side, the tangent and the inverse tangent will cancel each other out, which means x is the inverse tangent of 9 over 21. So on your calculator, you're going to hit second tangent and then type in that fraction. Second tangent, 9 divided by 21. That would, again, we're going to round that to the nearest hundredth, 23.20, and that would be in degrees. Again, you should pause this video and try the next 2 on your own before you watch the solutions. If you're still a little bit confused, watch one more set, then try to do the next set on your own. There's about 10 or 12 of these, so we should have plenty of practice. Alright, 51-degree angle, 14 would be your opposite, x would be your hypotenuse. Again, hypotenuse is always across from the right angle, opposite is across from the angle we're dealing with. So again, we need to think to ourselves, which one am I going to use? Sine, cosine, or tangent? Well, I've written opposite and hypotenuse. That means this is a sine problem. So the sine of 51 degrees equals 14 divided by x. This means this is exactly like the first problem we did. We're multiplying both sides by x, which would give us x times the sine of 51 degrees equals 14. And then we are dividing by the sine of 51. So x would be 14 divided by the sine of 51 degrees. And we would feed that to the calculator. 14 divided by the sine of 51. And we would get 18.01 units. Again, it's a side length. We don't have inches or centimeters or anything like that, so we're just going to mark it with units. 23 is exactly like 21. We're finding the variable x. We are given the opposite and the adjacent, because this is the hypotenuse. We don't have that. So again, when we're figuring out which one to use, we're using tangent. So the tangent of x is 14 over 29, which means x will be the inverse tangent of 14 over 29. Anytime you're finding an angle measure, you will use an inverse trig function. So we're going to feed that to the calculator, second tangent, and then type in 14 divided by 29. That would be 25.77, and that is an angle measure, so that would be in degrees. Again, if you think you know what you're doing, pause it. Try the next two. All right, 63 degrees. We're given 16 is opposite, x is hypotenuse. So again, we're looking at SOHCAHTOA to figure out which one we're doing. We have opposite and hypotenuse, that is sine. So the sine of 63 degrees equals 16 over x. Now we've done two examples where x was in the denominator. Anytime x is in the denominator, we end up switching it with the left side of the equation. So x would be 16 divided by the sine of 63 degrees, or 17.96 units. Now if you're unsure how I did that, go back and look at the examples for numbers 22 and 20. It is exactly the same work. Alright, 25 is a little bit different. Here we have x is the opposite and 22 is the hypotenuse. So it's not really different in how we start. We still need to figure out which trig function to use. So we still consider SOHCAHTOA, and we say to ourselves, well, we have opposite and hypotenuse, that is sine. So we set up our equation. The sine of 21 degrees equals opposite over hypotenuse. This is where the major difference arises. Notice that x is not on the bottom, x is on the top of the fraction. This is essentially the third type of problem here. We had x was the angle. We solved those with inverse trig functions. We had x was in the denominator, like this one over here, in which case we end up dividing. When x is in the numerator, all we have to do to solve is multiply each side of the equation by the bottom, in this case 22. So x would equal 22 times the sine of 21 degrees. And we would feed that to the calculator. 22 sine 21 is 7.88 units. Again, pause it, try the next few, then watch more of the video. On 26, we're dealing with this 45-degree angle. Now this one's in here because people get tricked by this all the time. If we're looking here, x is our hypotenuse, and 35 is our opposite. It is across from the angle we're working with. So when we pick out our SOHCAHTOA for this problem, we're dealing with opposite and hypotenuse, that is sine. So the sine of 45 degrees equals opposite over hypotenuse, 35 over x. X is on the bottom. That means we're going to be dividing 35 by the sine of 45 degrees. We're going to feed that to the calculator. 35 divided by the sine of 45 degrees. Now what it's going to do is it's going to print out an exact value of 35 root 2 units. Feel free to give me that. That's fine. Or convert it and give me the decimal. It doesn't matter which one you give me. I will give you points for either one. 35 root 2 is approximately 49.5 units. Okay, 27 is yet another thing where they're trying to trick us. Notice they gave us three side lengths this time. You just need to pick two of them. It does not matter at all which two. So let's say we'll use the hypotenuse, which is 85, and the adjacent, which is 51. In that case, if those are the two we choose to use, then we're going to set up a cosine equation. You could just as easily use 68 and 85 and use sine, or 68 and 51 and use tangent. It does not matter. So the cosine of x, which is our angle, would be adjacent over hypotenuse, 51 over 85, meaning that x is the inverse cosine of 51 over 85. So we're going to feed that to the calculator. Second cosine, 51 divided by 85. That would be 53.13 degrees. Now, just so that you see this, let's say that we chose to use tangent instead with these red values, opposite and adjacent. We would set up tangent of x is opposite over adjacent. And then we'd do the same thing. We would take the inverse tangent of 68 over 51. Guess what? Feed that to the calculator, 68 divided by 51. Oh my God, it's exactly the same value. So it doesn't matter. It doesn't matter which trig function you use. If they give you all three side lengths, pick two of them and solve for x. Okay, I believe that these two might be the last two of these. No, there's two more. Okay. So again, in 28 they gave us all three. It doesn't matter which two you choose to use to find x. So let's say that we use opposite and hypotenuse. Then we would use sine. It doesn't matter which two we choose. We just need to pick two and set up a trig function. So the sine of x would be opposite over hypotenuse, 51 over 85, and x would be the inverse sine of 51 over 85. Feed that to the calculator, and we get 36.87 degrees. All right, on 29, we're back to ones where it does matter which trig function we use. So again, we just need to figure out which one are we supposed to use, sine, cosine, or tangent. Well, there's the angle. 28 is adjacent, x is hypotenuse. Adjacent and hypotenuse would mean cosine. So the cosine of the angle, 47 degrees, is the adjacent over the hypotenuse. X is on the bottom. That means x is equal to 28 divided by the cosine of 47 degrees. Feed the calculator. And x is 41.06 units. Again, you should pause this before you try the next two. You should try them on your own. Don't let me do them for you. It doesn't do you any good to use this video if you're not trying on your own. Alright, again, we've got another one of these tricky ones. In this case, x would be the hypotenuse because it's across from the right angle, and 34 would be the adjacent. So when we go to SOHCAHTOA, kids always have trouble when the hypotenuse is set up as the base of the triangle. I don't know why. We are going to be using cosine because we have adjacent and hypotenuse. So the cosine of 59 degrees equals adjacent over hypotenuse. X is on the bottom, so x would equal 34 divided by the cosine of 59 degrees. Feed the calculator. 34 divided by the cosine of 59 degrees. That would be 66.01 units. Final problem like this, final SOHCAHTOA problem, involves 10, which would be your opposite, and 39, which would be your hypotenuse. Again, the key skill here is being able to identify which trig function to use. Opposite and hypotenuse would be a sine. So sine of x equals opposite over hypotenuse. X is the variable, is the angle, so we'd use an inverse sine of 10 over 39, and our answer would be in degrees. So feed the calculator. Second sine, 10 divided by 39, would be 14.86 degrees. That should take care of that section. Now there is another section at the bottom of the 4th page, so let's go ahead and talk about those, and that is converting between degree measure and radian measure. Now this is all based on the fact that pi radians is equal to 180 degrees. And what we're doing are unit conversions. Okay, we're doing dimensional analysis from your science classes. We are going to convert radian measures to degree and degree measures to radians. So for instance, 165 degrees. What we do is we put that over 1 and we multiply it by the conversion factor, pi radians over 180 degrees. The reason we do that is degrees will cancel, making our measurement in radians. So that would be 165 pi over 180, which we would then reduce. Now I would point out that if you use your fraction button, it will reduce that fraction for you. That reduces to 11 pi over 12 radians. 33 is in radians to begin with, so we would start with 7 pi radians over 12, and instead of multiplying by pi over 180, we would multiply by 180 over pi. Again, the point here is so that radians will cancel and place us in degrees. Now, in addition to radians canceling, pi should cancel as well. So what we're looking at here is 7 times 180 divided by 12. So 7 times 180 divided by 12 is 105 degrees. Again, you should pause the video and try the others on your own. 235 degrees over 1 times 2 pi radians, not 2 pi radians, slow down. Okay, times pi radians over 180 degrees. Degrees cancels, giving you 235 pi over 180. And 235 over 180 reduces to 47 pi over 36. And that is in radians. 7 pi over 5 radians. Radians is on top. We're going to multiply by pi radians over 180 180 degrees over pi radians. Radians and pi will cancel. So we're looking at 7 times 180 divided by 5. 7 times 180 divided by 5 is 252 degrees. 115 degrees over 1. We're going to multiply by pi radians over 360 degrees. Degrees will cancel. I wrote degrees twice. I'm not really sure why I did that. I think because I'm getting tired. And we end up with 115 pi over 360. 115 over 360 reduces to 23 over 72. So that would be 23 pi over 72 radians. And finally, 3 pi radians over 8 times 180 degrees over pi. You know, I just noticed a mistake. I got to go back here. I must be getting tired. I should have been multiplying by pi over 180 degrees. So this should be 115 over 180, which means that this is the wrong answer. So let's fix that. Smooth. Okay, 115 over 180 reduces to 23 over 36. So 23 pi over 36 radians. My mistake. And finally, okay, back to where we were. We're multiplying 3 pi radians over 8 by 180 degrees over pi radians. Pi and radians will both cancel, giving us 3 times 180 divided by 8. Or 67.5 degrees. Check real quick to make sure I didn't make any other stupid mistakes. I did not. And that completes pages 3 and 4 of your review packet.